sphere. You are asked to find electric field at a point P, which is outside the sphere, and at point M, which is inside the hollow sphere. So I begin with hollow sphere. So this is a hollow sphere with center O, and the radius of hollow sphere is R, and you are asked to find electric field at point P, which is outside the hollow sphere, and at point M, which is inside the hollow sphere. I will find electric field at point P and point M through Gaussian law. I apply Gaussian law in 3 steps. I just find Gaussian surface. In first step, I just find Gaussian surface. Find Gaussian surface. In second point, I formulate Gaussian law in mathematical form, that is flux E dot ds is nothing but q enclosed by it over epsilon naught. And in third step, I find the value of integral of ds, which is area of Gaussian surface, and q enclosed by it. So as you know, when you give charge to a hollow conducting sphere, the charge reside over its surface. When you give a charge to hollow conducting sphere, the charge will reside over its surface. Suppose you give a charge q to it, and you are asked to find electric field at point P and point M. So the first step is you will make Gaussian surface at point P and at point M. In both the cases, the Gaussian surface gonna be a sphere. In both the cases, the Gaussian surface gonna be a sphere. That the radius of outside sphere be R1, and the radius of inside sphere is R2, and the radius of hollow sphere is capital R. This is R2. Now we are done with Gaussian surface, and the second step is to formulate Gauss law in mathematical form. E dot ds, that is flux, is nothing but q enclosed by Gaussian surface over epsilon naught. It is dot product E dot ds. Let me show you something, that electric field is directed away from sphere, and the direction of this sphere is also in same direction, that is normal of sphere, and this is the direction of electric field. Both are in same direction, so the angle between them is 0. So I will write E dot ds as E ds, because angle between them is 0. And I will carry out E. I will carry out E outside the integration, because E is constant on each and every point on Gaussian surface. At every point on Gaussian surface, E is fixed. So you can bring E outside the integration. We will just left with ds inside the integration and q enclosed over epsilon naught. The area of Gaussian surface is the integral of ds is nothing but, this is our third step, 4 pi r1 square, and q enclosed by it is capital Q. Now put the value of ds and q enclosed in second expression. You will get your answer, that is the integral of ds is 4 pi r1 square equal to q upon, this is q enclosed upon epsilon naught. So when you do some calculation, you will get q over 4 pi r1 square times epsilon naught, 4 pi epsilon naught, 1 upon 4 pi epsilon naught is kq over r1 square. It is similar to that of a point charge. So this is electric field at outside point, that is kq over r1 square. Now This time you have to calculate electric field at point M. So the first step is finding Gaussian surface, and in this case the Gaussian surface is once again sphere, and applying mathematical formulation of Gauss law that flux is q enclosed by epsilon naught, and finding third step is like finding integral of ds and q enclosed. In this case, the charge enclosed by inner sphere is 0. So in, when you are calculating electric field inside the hollow sphere, you will see that when r2 is less than r. When you are calculating electric field inside the hollow sphere, you will see that charge enclosed by it is 0. So the whole expression becomes 0. So electric field inside point is become 0. So this is our required answer for hollow sphere. Now let's move towards solid sphere. Suppose this is a solid conducting sphere. This time when you give charge, it will spread inside the sphere also. Means this time charge is also present inside the bulk of sphere, and you are asked to find electric field at point P and point M. Once again, point P is outside the sphere and point M is inside the sphere. Let me change the color. Similarly, you have to make Gaussian surface for point P and point M to calculating electric field at point P and at point M. The Gaussian surface is gonna be a sphere. Once again, the Gaussian surface is gonna be a sphere for point P as well as for point M. Okay, the radius of solid conducting sphere is capital R, and the radius of this sphere, which is outside the which is bigger than solid sphere, is R1, and that of small sphere is R2. Now we are done with first step, that to finding the Gaussian surface. For both the cases, the Gaussian surface is gonna be a sphere. And second step is to formulate Gaussian law mathematically, that E dot ds is nothing but q enclosed by it over epsilon naught. Suppose the charge q is given to the sphere, then it will spread uh, over its bulk, means it is present over the surface inside the bulk everywhere uniformly. And in third step, we do calculation regarding integral of ds and q enclosed by it. Now for outside point, for outside point, for outside point, uh, let me uh, let me tell you one more thing. In this case, E dot ds is once again EDS, because angle between E and ds is 0. So I will just write E dot ds as EDS, and I will bring out E outside the integration, because once again at Gaussian surface the electric field is constant, and as we know, on Gaussian surface electric field always remains constant, so we can we can bring out E outside the integration. Now let's begin. At point P, the Gaussian surface is sphere, and the radius of that sphere is r1, which is greater than radius of solid sphere. So I am applying, the first step is done. I am applying second step, that is formulating E dot ds equal to q enclosed by it over epsilon naught. E can be carried out outside the integration. You can bring out of the integration, and the value of ds, third step, the value of ds is 4 pi a square, 4 pi A square. A means radius. Here radius is R1 square. And Q enclosed by it is Q. The big sphere that is R1 of radius R1 is enclosing whole charge that is Q. So Q enclosed by it is Q, and epsilon naught as it is epsilon naught. So E once again come out to be K over 4 pi R1 square epsilon naught, and you can write 1 over 4 pi epsilon naught as K. So it become KQ over R1 square. This is once again like a point charge. So we are done with our electric field by solid sphere outside the outside point. Now we have to calculate electric field at a point which is inside the solid sphere. Now this time, the first step is for applying Gaussian law is done. It is once again Gaussian to find Gaussian surface, and once again it's a sphere of radius r2 So first step is like Gaussian surface. So Gaussian surface is a sphere of radius r2 which is less than radius of solid sphere. Second step is to formulate it Gaussian law mathematically. E dot ds is nothing but q enclosed by it over epsilon naught, and E dot ds is EDS because once again the angle between